Hi guys, equations of a straight line, y is equal to mx plus c. Okay, so what we're going to be learning objective is to be able to understand that linear functions, okay, straight line graphs can be in the form of y is equal to mx plus c, okay, and they represent a straight line. Anyways, what I'd like you to do as a quick starter, after hopefully copy down the title and the date for me, is work out the following mathematical anagrams, and for question 2, write down the equation for these lines here below. Okay, so what are those equations? So please pause the video, then press play when you're ready to carry on. Okay, what is the first word? It's all muddled up. It's gradient, okay? You probably came across that word, but we're going to be learning that in the coming lessons, okay? The next one's called an intercept. And finally, origin, okay? So it's the center of a graph, origin. Question 2 now, write down the equations for the lines below. So this one will have to be x is equal to 3 because any point on that line there, the x coordinate would be 3. Okay. All right. What about this one here? This will be x is equal to minus 5 because if you pick any point on the line there, the x coordinate would be minus 5. Okay. And this one will have to be y is equal to minus 4 because again, if you pick any point on that line there, the y coordinate this time would be the same and it would always be minus 4, okay, on that line. A way to remember this is all the vertical lines, okay, is x is equal to something, and all the horizontal lines is when y is equal to something, okay? We're just going to quickly go through this, a recap actually. Horizontal straight lines, so this is a horizontal straight lines, okay, we saw it in the starter. Like I said before, if we pick points on that line, so for instance 0, 5, 1, 5, 2, 5, 3, 5, 4, 5, and 5, 5, what do they all have in common? They have the same y value of 5, okay, or the same y coordinate of 5. So therefore the line is called y is equal to 5, okay? Please make a note of this. This is very important. The reason why that line is called y is equal to 5 is because any point on that line, the y value will stay the same at 5, okay? All right. Horizontal lines parallel to the x-axis have points whose y values are always the same. Okay, make a note of that for me, please. Vertical straight lines now, okay? This example of a vertical straight line, if we pick the points here, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6, what do they all have in common? The x value stays the same, okay? They have the same x value of 3, or the same x coordinate of 3. So therefore, this line would have to be x is equal to 3. That's what we call it, okay? And it's not only those 6 points that we picked, it's any point on that line, the y value or the y coordinate will be the same. It would always be 3. So vertical lines parallel to the y-axis have points whose x values are always the same. What I'd like you to do now is to pause the video and have a go sort these out. Which ones are horizontal, parallel to the x-axis, and which of these equations are vertical, parallel to the y-axis. So please pause the video, have a go, then press play when you're ready to carry on. So x is equal to 3 would have to be a vertical line, okay? Y is equal to 2, horizontal. X is equal to 0. Yeah, okay. There you go. All right. So we know what horizontal and vertical straight lines are. What I'd like you to do now is to pause the video. You don't need to draw the graph. Just label for me the equations for A, B, C, D, E, F. Okay. What are those equations for me? So please pause the video, then press play when you're ready to carry on. Okay, so A is a horizontal line at 3, so it would have to be y is equal to 3, remember. All the horizontal lines are parallel to the y-axis, so that's one way to remember it. Okay, sorry, parallel to the x-axis. Okay, so y coordinate stays the same. B now, x is equal to 2, okay, because that line is parallel to the y-axis and all the x value stays the same, okay, they have the same x value of 2. C, y is equal to minus 5 because they have the same y value. All of the points have the same y value of minus 5. D now is x is equal to 5 because all the points on that line have the same x value of 5. E now, x is equal to minus 3 because all the x values on that line all the points have the same x value of minus 3. and f is equal to y is equal to 0. Okay. What I would like you to do now is on your books, using a graph, okay, draw these 6 equations here on your graph. So please pause the video, then press play when you're ready to carry on. So ay is equal to 5, that line over there. X is equal to 1 is a vertical line. Y is equal to minus 3 would have to be a horizontal line cutting at minus 3. X is equal to 6 is again a vertical line cutting at 6. T is equal to x is equal to minus 1, another vertical line that cuts at minus 1, and y is equal to minus 5, so it cuts at minus 5. Okay. Given an equation for a graph that is not horizontal or vertical, we can sketch its graph using its gradient and y-intercept. Suppose we want to sketch y is equal to 2x plus 3. So 2 is the gradient or the slope of the graph. The gradient is always the coefficient of x. 3 is the y-intercept, or where the graph cuts the y-axis. And the y-intercept is always the constant, or the number on its own. Let's just explain this another way. So y is equal to mx plus c. M is the gradient and the c is the y-intercept. Please make a note of this one here. All the straight lines have a general formula, y is equal to mx plus c. Okay. So the m is our gradient, and the gradient basically means is how steep a line is, and the c is the y-intercept, so where it intersects the y-axis, or where it cuts the y-axis. That is what we call our y-intercept. Okay. So please make a note of this. So just going through a few equations here, y is equal to 3x plus 8. So as you can clearly see, remember the equation of a straight line has the form y is equal to mx plus c. And the reason why we want it in the form y is equal to mx plus c is because it makes it easier for us to identify exactly what our gradient is and what our y-intercept is. Okay, just from the equation alone, I don't even need to draw the graph. Okay, so my gradient here would be 3 for the first one, and my y-intercept would be 8. Question 2 now, y is equal to 4x minus 7. The m is my gradient is 4, and the c would be minus 7. So minus 7 would be the y-intercept. Question 3 now, y is equal to minus 2x minus 10. Be careful. Remember, the gradient would have to be the coefficient of x. So a lot of people would say 2. No, it would have to be minus 2. Okay, that is the coefficient of x, would be your gradient for question 3. And the y-intercept would be minus 10. And then question 4, this one's a little bit more trickier now because 3y is equal to 6x minus 9. Now, as you can clearly see, it's not in the form y is equal to mx plus c. Okay, there's a coefficient in front of the y. So all I need to do to get rid of that 3 in front of the y, I would have to divide everything by 3. Okay, because 3y divided by 3 just gives me y. So if I divide the whole equation by 3, I'm left with y is equal to 2x minus 3. Now, this equation here makes it much more easier for me to work out what my gradient and y-intercept is, because it's in the form y is equal to mx plus c. So my gradient is going to be the coefficient of x, which is 2, and then finally my y-intercept would be minus 3. Not 3 alone, but minus 3 because there's a minus in front of it. Okay? Thank you so much for listening.